Alrighty, guys. So we left off last time talking about molar concentration of ions. And so we're gonna be just reviewing it real quick, and I'll have you try 419 on your own. Okay. But let's take a look at the molar concentration of this solution. So you have a solution of calcium nitrate, and this is the formula for calcium nitrate. Okay. Oh, sorry. Now, if you take a look at this, how many calciums are inside of calcium nitrate? One. There's 1 mole of calcium nitrate, right? So 1 mole of calcium nitrate, or sorry, calcium. I'm crazy. And then how many moles of nitrate are inside of calcium nitrate? 2. Okay. Everybody good with that so far? Okay. So what this is basically telling us is that for every mole of calcium nitrate that you have, you're going to have 1 mole of the calcium ion and 2 moles of the nitrate ion. Okay? So with that ratio in mind, the question is asking, if you have 0.12 molarity CaNO3, okay, so this is the concentration for CaNO3, what is the molar concentration of each ion? Okay, we just talked about how for every 1 mole of calcium nitrate, you get 1 mole of the calcium ion, right? So if you have 0.12 molarity, what's going to be the molarity of just the calcium ion? Yeah, 0.12. It's the exact same because it's a 1-to-1 ratio. You see how it's 1? It's 1. So it's going to be 0.12, 0.12. It's the same ratio. Okay, however, when you take a look at nitrate, nitrate is a 1-to-2 ratio. Okay, so if you have 0.12 molarity calcium nitrate, what's going to be your molarity of nitrate? 0.24. 0.24. It's going to be double because it's 1-to-2. You just need to multiply this by 2. Okay, and that makes sense because every time you or this compound breaks apart, it's going to break apart into 1 calcium and 2 nitrates. So if this is 0.12, that means you're going to have 0.12 of each of these, which combine for a total molar concentration of 0.24. Okay. Does that make sense? Yeah. You're just basically looking at how the ion breaks apart. All right, we're going to do a practice problem that's similar to this, but any questions before you guys try it out? Yes.
I want to get it like the concentration of oxygen is 0.12, but how is it that nitrate is 0.12?
Each nitrate is 0.12, but there's 2 nitrates, so it doubles. So every time one of this breaks down, you get 2 of each.
Oh.
So if it's 0.12, then you're going to get 2 nitrates for that. You're going to get double the amount. That's why. Okay. All right. So let me give you guys about 2 minutes. See if you guys can do the same thing for this one. Here you have magnesium phosphate. So you're going to have to write the formula for the ionic compound. It tells you that's 0.5 molarity. And so I want you to find the concentration for each ion. So take about 3 minutes to do that. We'll go over it and then we'll move on. Okay, so let's start by writing the formula for magnesium phosphate. Hopefully you got Mg3 and then parentheses, Mg3, PO42. Sorry, I forgot the 3 or the G out of my mind. Oh my gosh. Not my day again. Mg2. Oh my gosh. 3. Okay, there we go. Wow, I had such trouble writing that ionic compound. All right, everybody good with the formula? Okay. So let's figure out how many of each ion comes out. So every time magnesium phosphate breaks apart, how many magnesiums do we get? 3. So we'll get 3 magnesiums, and then we'll get obviously 2 phosphates. Okay. Everybody good with that so far? So if the concentration of magnesium phosphate, the entire thing, is 0.5 molarity, okay, we got to figure out how many, what the concentration for magnesium is. What's the concentration for just the magnesium ion? Yeah, 1.5. Oh my gosh, 1.5 molarity. Okay, and again, it's because it's a 1-to-3 ratio. Every time magnesium phosphate breaks apart, you get 3 magnesium. So 0.5 times 3. Make sense? Okay. And then lastly, for the phosphate, what is the molar concentration of phosphate? 1. It's going to be 1 molarity. Okay, so just keep that in mind. Yeah.
For this one, analyze probably use such one the bigger and smaller it like equal to the coverage 1.5 0.5.
Mm-hmm.
But why is the given number small than the other?
This one right here?
Yeah.
Yeah, because when you have it's for the entire molecule, but this molecule, when it breaks down, it produces multiple of the same ion, and that's why this is going to be smaller, because you get 3 for every 1 and 2 for every 1. That's why. Make sense? Cool. All right, let's move on. Okay, so next topic we're going to talk about is making solutions. Okay, and AP test loves adding this. So on the AP test, they're going to ask you some laboratory procedure questions, like how to do stuff in an actual lab. And one of their favorite questions is how to make a solution. Okay, so I'm going to go over a problem with you. I'm going to show you how to solve it and write the procedures, and then I'm going to have you guys do one on your own. Okay, so let's do 420. Okay, it's asking how would you produce 500 milliliters of a 0.85 molarity Na2SO4 solution. Okay, so whenever you do these types of problems, first thing you want to do is you want to figure out how many grams of that compound you need. Okay, so we start with 0.85 molarity Na2SO4. We need to produce 500 milliliters of it. Okay, and what we want to figure out is how many grams of Na2SO4 you need in order to make it. Because in a lab, you can't weigh out things in moles or molarity. You weigh things out in grams, right? So you have to find it in grams. Okay, so that's pretty simple. We're going to be using the molarity formula. So capital M equals moles over liters. And then we're just going to plug in our numbers. What value should we plug in for molarity?
0.85.
Yeah, 0.85. So 0.85 molarity.
And then divide by 1/2.
Yeah, so we got moles, and then your volume is going to be 0.5 because you got to turn this into liters, right? So you got to calculate for moles. So in order to isolate moles, we need to multiply both sides by 0.5. So on the left side, you'll get 0.85 times 0.5, and that will be your moles. Okay, so I'll give you guys a second to do the calculations for that, and that's going to give you your moles of Na2SO4. So see if you guys can calculate that out and see if you guys can convert that into grams. So I'll give you guys about 2 minutes to do that. And if you got questions, please ask me while you're doing it. Okay, so figure out how many grams of Na2SO4. Okay, so, or better question is, let's see if I got it because I'm out of it again. So for your moles, you should have gotten 0.425 moles of Na2SO4. All right. Okay, so what we need to do now is we need to convert this into grams. So in order to do that, we need to use the molar mass of Na2SO4. So we're going to set up a fraction. Just do a quick dimensional analysis. You're going to put 1 mole on the bottom. And for your molar mass, you should have gotten 142. Okay, 0.04 if you wanted, but it's okay if you didn't. Okay, and then you calculate that out, and you'll get about 60.4 grams of Na2SO4. Okay. All right, guys, since I'm out of my mind, did I do this right? Great. Thank you guys for teaching me. Appreciate that. Okay. So that's pretty much all the math we really have to do. We're just figuring out how many grams of Na2SO4 we need to make this solution. Okay. So basically what this is telling us is that, hey, if you got a container, all right, and that is 500 milliliters, and you want it to have a molarity of 0.85, you need to put in 60.4 grams of Na2SO4 in order to make this solution. That's pretty much what it's telling you. Okay. All right. Yes.
How are we supposed to know that it's supposed to be grams though?
You always want to find grams when you're trying to make a solution.
Alright.
Yeah, because in a lab you can only weigh out in grams.
Yeah.
Okay, so let's talk about how to write the procedure now. Okay, so when on the test they ask you to write the procedures, this is how you're gonna do it. All right, so when you write the procedure, it's pretty simple. The first thing you want to do is you want to write that you're gonna weigh out your 60.4 grams of Na2SO4. So after you do your calculations, not weight out. Sorry guys, English my second language. So you're gonna weigh out 60.4 grams of Na2SO4. So first thing you do is just write that you're gonna weigh out the number that you calculated in grams. And obviously that number is gonna change depending on your calcs. All right, step 2, you guys good for it? Okay, step 2 is very important. You want to add your Na2SO4 to a 500 mil graduated cylinder. Not graduated cylinder. Oh my gosh. Volumetric flask. And I'll talk about why that's very important in a second. But you're going to add your compound to 500 milliliter volumetric flask. And we do 500 milliliters because that's the size of the solution that you wanted. Okay. All right, so for those of you who haven't seen a volumetric flask before, it looks like this. You guys probably can't see it, but there's a line right there. And every volumetric flask has its own size. This one's 1,000. It'll tell you that it's 1,000. If you want a 500, you just use one that says 500. And the nice thing about these is that once you fill it up to that line right there, that tells you when it's exactly at 500 or exactly at 1,000 milliliters. Yeah, it's a fancy measurement. It's very precise. Okay, now, it's very important that we add the solid compound to the volumetric flask first. Okay, they take off points if you say add water first. Okay, and the reason why is because let's say I weighed out my solid right here. And let's say I added the water first. If I add the water first and then I add the solid, what happens?
It's gonna go.
Yeah, the volume is going to go past what you want it to. You want the volume to be exactly at what 500. And so you always want to add your solid first. Okay. Okay. Next, what you're going to do is you're going to fill to the line with water or distilled water. So basically, what you're telling them is, hey, you want to add your solid into your volumetric flask, and then you're going to fill it to the line with water. That's step 3. And step 4 is very simple. You just stir until it's homogeneous. Not stiff. Okay. So whenever the AP test asks you to write a procedure for making a solution, these are the steps that you want to follow. I mean, honestly, you can combine steps 1 and 2. You can just add 60.4 grams. You could do that as well. But these are the 4 steps I like to think about it. It's weighing, adding the solid, filling with water, and then stirring. Okay. Yes. Dude, I usually see at least 1 per year. Yeah. A lot of times it's gonna, sometimes I've seen it on the FRQ, usually in the, sorry, sometimes I see it on the MCQ, but most of the time it's in your FRQs. Yeah.
It's likely to be on our test.
Yeah, you'll have this on your test. Guarantee it.
Bro, you are not Charles.
I guarantee it. All right. Any questions about the procedures though? Is that pretty self-explanatory, hopefully? Okay. So I'll leave that up there for a second. Okay, so producing this solution, we're gonna start off pretty much the same way as before. We're gonna use a molarity formula. So you'll have 0.5 molarity, and that's gonna be equal to the moles divided by 0.15 liters. Okay, so far so good. Okay, so same thing. We're gonna multiply both sides by 0.15, the denominator. And that's going to end up with 0.075 moles of calcium chloride. So far, so good? Okay. Next, we convert this into grams. So we're going to find the molar mass of calcium chloride, which you guys should get to be around 111. Okay. And you calculate that out, and you should get about 8.3. I'm going to round that up to 3. Okay. But if you got something 8.3 around there, that's totally fine. Okay. All good so far? So that's it for the calculations. It's pretty easy. So now that we have our measurements, all we have to do is just change up the numbers and the chemical formulas in our procedures. So this time, you're going to weigh out 8.33 grams of CaCl2. You're going to add your CaCl2 this time to a 150 milliliter volumetric flask. And then you're going to fill with distilled water. What's up? No, we got 100. We got smaller ones. I think I have a 150 here somewhere. Yeah, it's a very small number, but we still want to use the volumetric flask regardless of the number. Yeah. But that's it. Any questions? Easy peasy. Everybody expert in writing procedures? You will have a problem like this on your test. I guarantee it.
Does that mean that we're not gonna have it?
No, you're gonna have it. I'm guaranteeing. I'm guaranteeing it. You know what? You can take it how you want. Everyone else, I guarantee it. Okay.
Okay, thank you for saying it normal way. Not.
I guarantee it. You're such nerds. Okay, ready to move on? All right, so that's enough of writing procedures. Now we're gonna go to something else. I guess this is another type of procedures. We're gonna be talking about something called dilutions. So this section is called dilutions. And you guys probably know the term dilute. It means something is less concentrated, or with our alcohol example that none of you guys have any interest in, it is weaker, right? Something that is more dilute is weaker. Okay. And the calculations for dilutions is really simple. It's this formula right here. I'm going to show you how to use it in a second, but make sure you jot it down. It's M1V1 equals M2V2. Okay, M1V1 equals M2V2. M1V1 equals M2V2. And I'm going to show you guys what this formula means. Just a second, but just make sure you guys have it copied down. Okay. All right. So when we have our dilution formula, you guys notice how there's two sides to it, right? And then there's molarity and volume for each side. So the one section, this right here, is what we call our stock solution. And this is the original solution. Okay, you can almost think of it as the stronger solution. Okay, stock, original, stronger. Okay. And the other side, the two side is the diluted. So this is the one that you want to make. So this is the diluted solution. Is what you want to make. Okay. So obviously the M is molarity. So M1 is the molarity of the stock solution. V1 is the volume that you need. M2 is the molarity of the solution you want to make. And the volume is the volume of the solution you want to make. Okay, yeah.
So I know water, usually like, especially if you have like salt or something.
Yeah.
It usually dilutes it.
Yeah.
But like, is there anything else that like this?
For the AP test, we're just gonna be using water. Yeah. Water is gonna be your solvent 99.9% of the time. Okay. All right, so let's do a quick problem. And then I think we'll be done. This is a pretty easy section. Okay. So 422, it's asking, how would you produce 250 milliliters of a 0.4 molarity Na2SO4 solution using a 0.85 molarity solution? Okay. So I'm going to set up my formula. And what we're going to do is we're just going to plug in our numbers using the definitions we just talked about. All right, now the question you want to ask is, as you go through this problem, look at the numbers and you want to ask yourself, is this number, does it apply to the original solution, the stock solution, or does it apply to what you want to make? Okay, so that's what you want to ask yourself. Okay, so let's take a look at the first number, 250 milliliters. Now, is 250 milliliters the solution you want to make or the solution that you start with?
You want to make it's the same.
Yeah, you want to make it. You want to produce 250 milliliters. So is this going to be V1 or V2? V2, exactly. So 250 is going to be your V2. You want to make 250 milliliters of something. All right, let's go to the next number, 0.4 molarity. Is 0.4 molarity the solution you want to make or the one you start with?
What do you want to make?
Yeah, it's what you want to make. Easy way to think about it is this number smaller, so it's going to be what you want to make. What's up?
Why does it matter though? Because no matter what side of the equal sign it's on.
Yeah, but it's just an easy way to bookkeep. Yeah, but if you're comfortable switching sides up, that's fine. Okay, and then lastly, you are using a 0.85 molarity solution. So that means that's going to be your M1. And so you are looking for V1. What the freak?
I don't even know how to go ahead.
All right, guys. So for the math, this should be pretty easy, right? All you have to do is divide both sides by 0.85 molarity. And that is going to give you the volume of the solution you want to make. So let's punch this into our calculators. I'll give you 30 seconds to do that. See if you guys can get the final answer and see if you guys can write the correct unit of measurement. Okay, we need to label all our numbers with the unit of measurement. Take 30 seconds. Okay, so we're gonna get 0.4. Oops, we can get 0.4 times 250 divided by 0.85. That'll give you 117.65. Everybody got that? Okay. 0.65, and the correct unit of measurement is milliliters. All right, so let's talk about, yes. Not for dilutions, you don't need to. Yeah, it's just ask me a question, dude. Let Okay, next time you ask a question, I'll be like, that's a simple question. Why are you asking? Imagine not knowing. I'm just kidding. All right, no, you're good. No, I'm kidding. All right. So what these numbers basically tell us is, hey, we have our stock solution. And our stock solution is 0.85 molarity. That makes sense? This is our OG solution. This is our stock. Now, you want to make a solution that's 250 milliliters, right? And is 0.4 molarity. That's basically the premise of the problem. The premise is you have a stock which is 0.85, but you want to make something that's a little bit weaker. So a lot of times, this happens in pharmacy. I worked at a pharmacy and you would have a stock solution where they give you a pretty concentrated form of a drug. But you can't give concentrated forms of drugs to your patients because a lot of times that leads to abuse, could lead to overdose. It's just not the best way to take it. And so we would have to dilute it. We would have to make it a little bit less concentrated before the patients could take it. And that's where dilution comes into play. So our calculations are basically telling us, hey, you're going to take 117.65 milliliters of your stock solution. You're going to put it into this container right here, the new container. And then you're going to fill it up to 250 milliliters. That will give you a 0.4 molarity solution. Does that make sense? That's pretty much what diluting is. You're just taking a little bit of the stronger one, and then you're making a new weaker solution out of it. Okay. So yes, I worked at a pharmacy, so I was a drug dealer for a bit. Legal drug deal.
Like a lot of people are illegal.
No, I'm good.
If you're a drug dealer, does this call yourself a pharmaceutical distributor?
You can. All right. Does that make sense, guys, for dilutions? Let's try a problem. I'll have you guys try it on your own. This one's gonna be worded a little bit differently. But I guarantee you it's a dilution type of problem. So take a second to do 423, and then we'll go over it together. All right, so before we do the actual calculation, let me go over what's going on just so we can visualize it. So in this question, it's asking, what's the concentration of a KOH solution that was prepared using 250 milliliters of a 5 molarity KOH solution? So your stock solution, this is your stock. Okay, what is the concentration of your stock solution according to this problem? 5. It's 5 molarity. How much of the stock solution did you take out? 250. So you take out 250 mils of your stock solution. You put it into a 1,000 milliliter
Wait,
volumetric flask. Yes.
is it volumetric flask or
No.
so you're just putting 250?
Yeah. Mhm.
1,000.
Yeah. So your final volume will be 1,000. And the question is just asking you.
And adding 750.
Yeah, that's implied that you're adding 750. Yeah. So it's asking you what is the new concentration. That's pretty much what the premise is. That makes sense, everybody? Okay, so we go M1V1 equals M2V2. Hopefully it's not too bad. You put 5 for your stock molarity, 250 for your V1. You're looking for M2, and then you put 1,000 right here. Okay, so to solve it, you're just going to divide by 1,000 on both sides. So you multiply the tops together. So you got 5 times 250 divided by 1,000, and you should get 1.25 molarity. Okay, and an easy way to check your answer, your M2 should always be smaller than your M1. Okay, which it is, 1.25. There you go. That is dilutions. That's all we're going to do for dilutions. And congrats, guys. One last topic and we're all done.
Yay.
One more. And the last one, you guys are familiar with half of it already. So, yes, sir. All right. So let's jump right into the last one. And this is going to be solution stoichiometry. So you guys already know stoichiometry, right? Everybody's stoic experts here. Now we are doing it with molarity and volume and things like that. All right. So if you guys take a look at this problem and you feel confident doing it on your own, just ignore me and just try solving it. But I'm going to start going through it step by step for the first one. Okay. So it's asking how many grams of CaOH2 are needed to neutralize 25 milliliters of 0.1 molarity HNO3. So, whoa, what's going on? So what we want to do first is we want to write the balance equation. So the two compounds that are reacting together are CaOH2, calcium hydroxide, and HNO3. Now, if you take a look at these compounds, what do you notice about them? Yes, acid and base, strong acid, and you got a base. Okay, yeah, and it says neutralize. All right, so when you react to acid and base, what is one of the compounds that always forms? Salt and water. So your water is going to be H2O or HOH, and your salt is going to be calcium nitrate, which is CaNO3 2. Right, so there you go. That is your balance equation. So what you're going to do is you're going to balance, or it's not balanced yet. You're going to balance the equation. And then after that, you are going to use these numbers in order to figure out how many grams of CaOH2 you're going to produce. Okay, so I'm going to give you guys about 2 minutes. See if you guys can start by balancing it. And then I'll come back in. I'll help you set up the start of the problem. But again, if you guys feel comfortable just going all the way to the end, just go ahead. But at least try to balance it in the next 2 minutes. Okay, and we'll start going over it. All right, so for your balancing, you should have gotten a 2 right here and a 2 right here. Okay. Well, based on everybody writing, I guess not everyone was good with it. Okay, so what we want to do is we want to start with HNO3 because that's the one that we have all the numbers for, right? So it tells us in this problem that we have 25 mils of HNO3 and the molarity is 0.1 molarity. And what you want to end up with is you want to end up with grams of CaOH2. Does that the premise makes sense, right? Okay. So what we're going to do is we're going to take the numbers that we start with and we're going to try to manipulate it in order to find grams. Now we know that based on what we've learned, that if you find moles, you can find grams, right? Using the molar mass. So what we're going to do is we're going to use these numbers right here in order to find moles. So we're going to use the molarity formula. Hopefully you guys are able to see that it is 0.1 molarity is equal to moles, and then our liters is going to be 0.025 liters. And so if we solve this problem, it's going to give us the moles of HNO3.
Well, oh yeah.
And once you find moles of HNO3, you can convert that into moles of calcium hydroxide. So you're going to find moles of HNO3. You could find this.
So once you find it, you just do it again.
Yeah, and then you're going to convert it into grams. So solve this formula first right here. I'll circle it in red. Once you solve this, you could take your moles of HNO3, convert it to moles of CaOH2, and then convert it into grams. So I'll give you guys about 3 minutes to try finishing that up. We'll go over it in 3 minutes. Just because it is the first one, and then I'll give you guys a problem to try on your own. Okay. All right, guys. So what you want to do is you want to convert HNO3 into CaOH2. So since you got moles from this equation right here, right? We got this right here. We're gonna set up a fraction. You want to get rid of moles of HNO3, so we put that on the bottom, and we are looking for CaOH2, right? So we're going to have moles of CaOH2 on the top. Everyone got that? Okay. You have 2 moles of HNO3 for every 1 mole of calcium hydroxide, so 2 to 1. And that lets us cancel out moles of HNO3. Lastly, we're going to convert that into grams. So we're going to convert 1 mole of CaOH2. And then the molar mass for calcium hydroxide is 74. And there you go. That's going to let you cancel out the moles, and that gives you grams. Any questions on any of those steps? Or are you guys chilling with
I
that?
have a lot of questions, nothing about that.
All right. What's your question?
So like, what? Do you remember?
Eventually. Eventually.
How many questions did it take?
Oh, I'm asking about this, not my story. Any questions about the solution stoichiometry problem? I know you guys are fascinated by my poop stories, but yeah, I'm blacked out, dude. Final answer, you're gonna get 0.093 grams of calcium hydroxide. All right, everybody good?
Yes, sir.
All right. All right. So this is the equation that we're working with. Now, if you take a look at this problem, it's asking us for the unknown concentration. So if we're looking for concentration, what's the unit of measurement we're looking for?
Molarity.
We are looking for molarity. That means that problem needs to end with molarity. Specifically, molarity of what?
HCl.
Yeah, HCl. Wow, good job, guys. So you are looking for molarity of HCl. Now, if you guys take a look at molarity, you guys should remember that molarity is equal to moles divided by liters, right? Specifically, since it's molarity of HCl, it'll be the moles of HCl. Okay. So to find molarity of HCl, you need moles of HCl and liters. Okay, which one of these do we have?
We have 0.1 liters.
We have 0.1 liters already. We have 100 mils of HCl, which means this right here on the bottom is going to be 0.1 liters. So far, so good?
Yes.
Okay, that means we need to find moles of HCl in order to finish up this problem. Okay, does that part make sense so far, guys? Okay, so what we're going to do is we're going to take the remaining numbers that we have. We got 25 mils of NaOH. and we have 0.1 molarity NaOH. And then from there, you guys should see it's pretty similar to what we just did. We're going to take the molarity of NaOH, and we're going to use that to find the moles of NaOH. Okay. Once we find moles of NaOH, we should be able to calculate the moles of HCl. Okay. All right, I'll pause right there because it looks like people are copying down or finishing up. But does anyone have any questions on why we set it up that way? Or does that make sense now? Yeah.
So neutralize means it's neither acidic nor basic.
Yeah, to cancel that out completely.
What if it's not like an OH and an H2O? How would you know if it's canceled out then?
There's another value that we're gonna use, but that's not the acid base, so don't worry about that. Okay, guys, so we're gonna calculate for moles of NaOH. To do that, we're gonna do 0.1 times 0.025. And so for the answer for this part right here, it'll be 0.0025 moles of NaOH. Okay. And what we have to do now is we need to convert this into moles of HCl. Okay. Make sense so far? Love it when it's quiet. Okay, so we're going to take 0.0025 moles of NaOH, and we want to turn it to moles of HCl. Okay. So we can set up a fraction if you want. 1 mole of NaOH, right here, it's 1, is equal to 1 mole of HCl. So some of you guys might have been able to see it's just a 1-to-1 conversion, so you didn't need to set this up, because it'll be 0.0025 moles of HCl. Just divide it by 0.1, and then you get your molarity. And that's it. So molarity of HCl is equal to 0.0025 moles of HCl divided by 0.1 meters. That should give you 0.025 molarity of HCl. And there you go, guys. That is that problem. All right, so I gave you the equation for 4.26 and the states of matter. If any part's hard to read, please let me know. I can clarify for you. But I'm going to give you guys I'll give you 6 minutes to do both parts A and B, and then we're going to start going over it. And that should be about how long it takes you to solve this problem on your own. Take about 6 minutes. And that's it for the unit, guys. All right, so we got the equation already. Now, we're going to take the numbers that we have and solve part A. Part A is asking for liters of HCl solution, okay? So if you guys notice, our starting values are 0.04 molarity of the lead nitrate. Okay, and you have 100 liters of it, 100 milliliters. That's going to be 0.1 liters. That's going to allow us to find moles of PbNO3 Okay, everybody good with that setup so far? Okay, so if we multiply these two values, that's going to give us our moles of lead to nitrate, and that's going to be 0.004 PbNO3 All right, and then from there, since we are looking for liters of HCl, we want to turn this into moles of HCl. Oops, sorry. Okay, so we're going to set up our fraction. You have 1 mole of lead nitrate for every 2 moles of HCl. Okay, so that's going to give you 0.008 moles of HCl. And then since you're looking for liters this time, we just plug it into the molarity formula. 0.5 molarity is equal to 0.008 moles of HCl. And then we just need to solve for liters. And if you solve that out algebraically, you should get 0.016 liters of HCl. Yes. No, that's for dilution. This is not dilution. Sorry, what was that? Oh, did you use M1V1? Okay, that works too then, yeah.
No, no,
There's
that's-
multiple ways to solve it, but as long as you got the same answer,
What'd you get?
that should be fine.
Yeah, the answer 0.7.
Yeah, 0.016. Okay. Does that make sense though, the steps that we took?
Yeah.
First thing you do is find moles of lead nitrate, turn it into moles of HCl, turn it into liters. Okay. For part B, we're looking for grams of the precipitate. The chemical that's our precipitate is PbCl2. And so we actually did a lot of the work already. We have our moles, so we can just start from our moles. So we're gonna take our moles of lead nitrate. Yes, we found that, but we also have moles of lead nitrate. We can also do it from here. Yeah, either or is fine. You can do it both ways. So you're gonna take our moles of PbNO3. You're gonna turn it. You're gonna do the mole ratio: 1 mole of lead nitrate and 1 mole of lead chloride. And then you can just use the molar mass of lead chloride, which is going to be 278.11 grams. And that will give you a final answer of 1.11 grams of PbCl2. That's it. So awesome. Okay. You can also have done it from the moles of HCl. We just need to change that first fraction. Okay. So you would have 2 moles of HCl for every 1 mole of PbC.
For 0.5, for that equation was the molarity.